Hello everyone, welcome to episode 8. We're going to start by talking about what our code does and how it works. Then we'll clean up the current code and I'll explain how the old coding style works. We will start by reading this line of code. uProperty, blueprint read only, visible anywhere, category equals default. To recap, uProperty is a macro that integrates with Unreal Engine's garbage collection system, ensuring the proper management and cleanup of variables. By specifying the blueprint read-only specifier in the uProperty declaration, the variable becomes accessible and readable within blueprints but remains immutable, meaning they cannot be modified through the blueprint editor. The visible anywhere specifier makes the variable visible and editable in the Unreal Editor across all property windows, but it is marked as read-only, meaning it can be inspected but not modified during gameplay or runtime. The category specifier organizes the variables under the meshes category within the Unreal Editor's property panels, helping the group and display related variables more intuitively for easy access during development. Remember, our uProperty goes before the code below. T-Object PTR or T-Object Pointer. This is Unreal Engine's smart pointer, specifically used for managing objects derived from uObject types, such as our uSkeletal Mesh component. It provides automatic memory management by ensuring proper reference tracking of the objects. We use T-Object Pointer to point our uSkeletal Mesh component to our variable face. uSkeletal Mesh component. This is a component type in Unreal Engine that is designed to handle skeletal meshes, which are 3D models with bones used for animations. In our case, uSkeletal Mesh component is used for face, which often requires a facial animation for expressions, speaking, and other dynamic movements. Face is the variable name for our component. Now I want you to adjust your code to what you see now, so pause and do so now. Now that you have changed your code, swap over to the MetaWarrior source file, also called our MetaWarrior CPP. We're going to talk about our definition face. Face is a variable where we store our reference to the newly created skeletal mesh component created in our header file. The next line of code, create default sub-object uSkeletal Mesh component. This is Unreal Engine's function used to create a sub-object within an actor or component. Here is creating a new skeletal mesh component, which is used to handle animated 3D models with bones. The template argument uSkeletal Mesh component indicates what type you're creating. The text face is the name that you're given to this component. It's useful in the Unreal Editor for identification and debugging. The text macro ensures that the string is properly handled by the engine for localization and other purposes. Face setup attachment. This function is used to attach one component to another. Here it's attaching the face to the base mesh of the character. Get mesh. This function retrieves the main skeletal mesh of the character, which typically represents the entire body. By calling setup attachment get mesh, you are ensuring that the face component will follow along with the main character mesh as it animates and moves. Now I want you to pause and change your code for your source file. In Unreal Engine, You can declare pointers to classes with the class keyword followed by the class type, which is uSkeletal Mesh component. In this case, it tells the compiler that face is a pointer to the class type. Using class is also referred to as for declaring. In C++, it's a way of telling the compiler that a class or struct exists without providing the full definition of that class or struct right away. Instead of including the whole header file with the class definition, you simply declare it at the front of your file. This also helps speed up complication and reduces dependencies between files. uSkeletal Mesh component. This is the class type we are pointing to. The asterisk indicates that face is a pointer to an object of type uSkeletal Mesh component. Pointers are variables that store the memory address of another variable or object. In this case, it will store the memory address of a uSkeletal Mesh component instance. Face is the name of the pointer variable. You can think of it as a reference to the skeletal mesh component that might represent a character's face. We have already gone over our source file code. It stays the same, so now we can build our project. Okay, what we're going to do now is we're going to add in our camera boom, aka the spring arm component, and we're going to add in our camera, and we're going to attach it to our spring arm in C++. We're also going to add our target arm length, which is what increases and decreases the length of the camera. So let's begin. The first thing I want you to do is go to help, go to documentation, scroll down to understanding the basics, and open up Unreal Engine terminology, and scroll down to character and click setting up character movement, and click the C++ button and scroll down. What I want you to do here is use this as a reference. The code that's right here, we're not going to use this. We're going to use our new pointer system. And for our includes, we're going to need this for both our source file and our header file. But you can just copy my code, but you can use this as a reference. Okay, now that we're back in our Visual Studios, I want you to copy these includes into your header for your header file. Now scroll down, and I want you to copy this code. Now we're going to go over to our source file, Metal Warrior CPP. And at the top here, you need to copy this code. Now scroll down, and I want you to copy all of this. As you may have noticed, we used a different object pointer this time. This time we used tweak object pointer, and I'll explain to you why. The reason we use tweak object pointer instead of object pointer is based on memory ownership and lifetime management. Ownership and lifetime. Object pointer is used for owning references to Unreal Engine objects, i.e. U objects. It ensures that the object it points to is valid as long as the owner exists. This smart pointer doesn't automatically prevent circular references, meaning it maintains a strong reference. Typically, object pointer is best used when you want to have a direct, strong reference to the object, ensuring that it won't get garbage collected while you hold it. Tweak object pointer. This is a non-owning reference that doesn't prevent the reference object from being garbage collected. When the object is destroyed, the tweak object pointer can safely detect that it's no longer valid by returning null pointer or checking its validity using is valid. This is typically used when you don't want to take ownership of an object or hold a strong reference that might lead to memory issues, such as preventing garbage collection. Why we use tweak object pointer for spring arm and camera. In this scenario, the spring arm component and camera component are created by the actor via create default sub object, which makes the actor their owner. The actor will manage the lifetime of these components. Tied to the actor's life cycle, when the actor, i.e. your character, a meta mage or a meta warrior, is destroyed, these components will be destroyed as well. By using tweak object pointer, you avoid taking ownership or responsibility for the lifetime of the components in the character class itself. If the actor gets destroyed, the weak pointer will automatically detect that the component has been destroyed and return null pointer when accessed, preventing the use of invalid pointers. Circular references. If we had used object pointer, it could increase the risk of accidental circular references, where both objects hold strong references to each other, leading to memory leaks. Tweak object pointer mitigates this by ensuring that the pointer doesn't prevent the destruction of the object. Now that we're in our source file, we want to go over our code now, and we'll start by going over our spring arm. The first line of code, we're creating a spring arm, which is like an invisible stick that controls how far the camera is from the player. We name it spring arm, which helps us identify it later. The next line attaches the spring arm to the character's root component, usually the character's capsule, so the spring arm will move and rotate along with the character. The next line, this sets the length of the arm to 300 units. It controls how far the camera will be placed behind the character. It's like a camera being held on a long stick. Next line, we tell the spring arm to rotate based on the player's input, such as moving the mouse or using joystick. So when the player turns, the camera will follow smoothly. And finally, this line just saves the spring arm we created so we can access it in the code if needed. Now let's go over our camera code. The first line, we create the camera itself, which is what gives us the actual view of the game world. The second line, we attach the camera to the spring arm. This means the camera will follow the spring arm's position and rotation. It's like putting a camera on the end of an invisible stick. Line 3. Here we tell the camera not to rotate on its own. Instead, it will be moved based on how the spring arm rotates. This gives the camera a smooth, controlled movement behind the character. In the next line, we store the reference to the camera so we can use it later if needed. Now let's go over our if statements. The if statement checks whether the spring arm pointer is valid, i.e. not null pointer. In other words, it's making sure the spring arm was successfully created by create default subobject. Why is this important? Sometimes, for various reasons, like memory issues, a new object might not be created successfully. If we try to use a spring arm that wasn't created properly, it could cause errors or even make the game crash. What happens in the if block? If spring arm is valid, it exists and was created successfully. The code inside the if block runs. In this case, it 1. Attaches the spring arm to the character's root component. 2. Sets the arm length to position the camera at a certain distance. 3. Allows the spring arm to rotate based on the player's input. 4. Saves the spring arm in a variable for later use. What if the spring arm isn't created? If for some reason spring arm is null pointer, meaning it wasn't created successfully, the code inside the if block won't run. This helps prevent errors by only executing the important setup if the spring arm exists. Why use this check? It protects your code by checking if the spring arm is valid before using it. You avoid crashes or unexpected behavior. It also makes the code more robust. It ensures that you only proceed with setting up the spring arm if it's properly created. So what we're going to do now is we're going to copy our code to our mage. So if you don't have your mage open, you can go over here to the mage RPG folder and go to your source folder and open up your Metahuman RPG folder and then your characters folder and then find your mage. You can just click on it and it'll open it up. Now, what you need to copy over from your mage warrior header is these two includes right here. You just copy paste it right here, right before your mage generated. Then you go over here and you copy paste everything you see right here. And then you post it over here in your mage. But in your mage, change the A meta warrior to A meta mage. And you'll be done with that. Then go over to your meta warrior CPP or your meta warrior source file and just copy everything from here. So everything from this point right here. Well, I need this one right here. Oh, frick. Let me see. Undo. There we go. Grab everything from here and copy paste it into your mage source file and delete the warrior part off of it and put mage So it should be a metamage, a metamage. And make sure you don't have an extra bracket down here so you won't have any issues. Make sure you don't have an extra bracket. And then after that, build your project. And then open up your project by going to start without debugging. So the first thing I want you to do is go to your content folder, or just press all and then go to your content folder and go to your Metahuman folder and find your other character that you added to your project other than the main one, and open this BP up. Now go to your viewport, and what I want you to do is up under face, I want you to click on eyelashes, then hold down shift and press beard, and then I want you to copy, which is Control C, and I want you to close this out. Then I want you to go back to your all folder, go to your content folder again, open up Metahuman RPG, then character, then your metamage BP, then go to your viewport and go to your torso and type in body. So whether you're using the male version or the female version, the male version is M tau and the female version is F mid. So click on that, and in your location in your transform put -90, and in your rotation put -90. Then we want to go down to our, well, actually what we're going to do first is going to copy paste, go in here and paste, and it'll put this in here, but it's going to put it under your torso, so you're going to have to drag it down to your face. So on your face, you need to type in the name of your character or your metahuman, and you'll see the name of your character and face mesh, and you click on that, and you do the same thing in your transform, -90 and -90 in location and rotation. And you're pretty much done. And compile and save. And what I want you to do is I want you to take your meta warrior and drag them in. And I want you to take your meta mage and drag her in or him in, whichever one you chose. And you can rotate it to face your camera. And as you can see, the lighting is a little bit bad, but how you fix that is you take from your place actors and put a point light in, and choose the translate one, and you pull it up, and you can push your character back a little bit, So the light will hit. You can drag her over or him over closer. And you can click on your light again and hold down Alt and drag out. And you'll have 2 lights now. If you enjoyed the video, hit the like and subscribe button. And if you would like to join my community, you can do so by joining communities.unrealengine.com/Memphis. See you guys next time.